Today we are going to work on how to find the other trig functions. Before we get started with that, we will talk a little bit and kind of refresh our memories on what sine and cosine and all those other trig functions are. So sine and cosine are our main guys, and remember we're talking about in a unit circle. We've seen how it doesn't matter the size of the circle, since sine and cosine are defined by x and y values divided by the ratio. It always comes back to the unit circle. So for our purposes, the radius is always 1. So sine is simply the y value, cosine is simply the r value. And then if we talk about secant of theta, that's 1 over your cosine value. Cosecant, recall, is 1 over your sine value. Tangent is the ratio of sine to cosine, and your cotangent is your ratio of cosine to sine, which, if you look at that closely, is really 1 over your tangent. So it's just a lot of flipping. So let's take these and use these into some sort of application here. And let's say you're asked to find the other 5 trig functions. Find the other 5, yes, I'm saying 5 on purpose, the other 5 trig functions or values, depending how you want to look at that. Find the other 5 trig values given, let's say that you're given that sine of some unknown angle is equal to 5/13, and that unknown angle, you're simply told, is between pi over 2 and 3 pi over 2. Alright, so there's the problem. We need to find the other 5 trig functions. We know sine, we need to find cosine, tangent, secant, cosecant, and cotangent. So what do we know? Well, this is what we know. We know that our angle is located between pi over 2 and 3 pi over 2. So my angle is somewhere in here. And somewhere in here really means either the second or the third quadrant. Okay, so this is a portion of the unit circle, right? 0 is over here. Pi is over here. If I continue around, this then becomes 2 pi. All right, so we're told the angle, theta, the angle, is between pi over 2 and 3 pi over 2. So I've narrowed it down to the second and third quadrant. Well, additionally, I know that sine is positive. It's a positive 5/13. Sine is my y-coordinate, and sine is positive in the second, but negative in the third. So here's my winning quadrant. I know I'm in the second quadrant. So what I'm going to do is I'm going to set up a triangle, a second quadrant triangle. Right, there's quadrant 2, and my triangle, what I mean by a second quadrant triangle, is this. With my central angle coming off the horizontal axis. Remember, our angles are always measured off the horizontal axis. That's why I've been doing these reference angles so much. Okay, now this stuff's starting to make sense here a little bit. So we got an angle off the horizontal axis. Sine, remember the official definition of sine is y over r. So if sine of theta is y over r, and I'm told my value is 5/13, that means my y value is 5, and my r value is 13. Whoa. That's a hypotenuse, not a radius. This is true. But let's draw our circle around here. Right? If our circle continues around, the hypotenuse of the triangle, think about how we derived all of our values on the circle. The hypotenuse is the radius of the circle. Remember, all these circles are built off of triangles. This is triangonometry, right? Trigonometry. We're dealing with triangles here. Everything's based off a triangle. So here we go. Let's continue. We've completed 2 sides of this right triangle. Pythagorean theorem, or hopefully known in Pythagorean triples, tells you right away that this component right here is 12. I have all I need right now. So now I can say that my cosine of that unknown angle, not 12/13, but because we're in the second quadrant, is negative 12 over 13. If I know sine is 5 over 13, that tells me that cosecant is 13 over 5. If I know cosine is negative 12 over 13, that tells me that secant of theta is negative 13 over 12. And if I know sine and cosine, I also know tangent. Tangent, remember, is the ratio of sine to cosine. Okay, so sine over cosine, think about this. I have 5 over 13 divided by negative 12 over 13. Dividing by a fraction is the same as multiplying by the reciprocal. Those hypotenuses are just going to cancel out. It's going to be my y value over my x value. Okay, in this case, second quadrant, we're going to have a negative 5 over 12. And if I know tangent, I know cotangent, the reciprocal, negative 12 over 5. Okay, let's do one more example here. And let's do the exact same thing. We're going to say find the other 5 trig functions. Find the other 5. If that first example is good enough for you, then be done with the video. If not, why don't you watch this one? Find the other 5 trig functions, or values again, whatever you want to call it. And the given information here, I will give you that tangent of theta is negative 3/4, and theta is going to be located between 0 and pi. So 0 and pi. 0 and pi. So that means I'm in either quadrant 1 or quadrant 2. Well, tangent's negative. Tangent is negative. First quadrant, sine and cosine are positive, which means positive over positive, right? Tangent's the ratio. That's also going to be positive. Here, second quadrant, sine is positive, but cosine's negative. Sine over cosine, positive over negative. Again, quadrant 2 is my winner. So I'm going to draw a second quadrant triangle again. Again, I'll color code this guy. So there's my triangle. Tangent, remember, is sine over cosine. Sine is my y value. Cosine is my x value. Okay, I am not going to put this negative sign in here because quadrant 2 tells me the negative and the positive nature of the values I need. Distance, though, is positive, so I want to keep that as a positive 3. Okay, in fact, the x value, the 4 here, is the negative piece. So another reason why the 3 will be positive. Complete our triangle here, right? And we know the hypotenuse, or the radius, is going to be 5. And our angle, remember, is located off the horizontal. So boom, we can wrap this guy up real quick here. Sine of theta, sine is positive in the second quadrant, y over r. Cosine of theta is 4 over 5, but we're in the second quadrant. If I know tangent, I know cotangent. Flip it, negative 4/3. If I know sine, I know cosecant. So that's 5/3. And if I know cosine, I know secant. Negative 5/4. And there you go, second example on how to find the other 5 trig functions given one trig function. Hope that helps. See you on the other side.